Hey, what's up everyone? Welcome to this new video with a returning guest that you might be quite familiar with if you've been following my channel for the past years. So welcome back, Natalia.
Thank you, Vincent. So happy to be here again.
So nice to have you again. So Natalia, just as a reminder, so you've worked as an Apple engineer on SwiftUI. You've written a book about SwiftUI, and you've also written a new book this time about advanced tips that you can use when writing Swift. And so you're going to show us, I think, three advanced tips that we can use to write better, more expressive Swift code.
I'm so excited to share with you some powerful Swift techniques related to control flow and pattern matching. We'll dive into three specific strategies: iterating over items and indices in collections, labeling loop statements to control execution of nested loops, and overloading the pattern matching operator for custom behavior. Let's get started by looking into different ways to iterate over items and indices in Swift collections. Iterating over both the items and the indices in a collection is a common requirement in Swift programming. While the enumerated method might seem like the obvious choice for this task, it's crucial to understand its limitations. The integer it produces starts at 0 and increments by 1 for each item, which is perfect for use as a counter, but not necessarily as an index, especially if the collection isn't zero-based or directly indexed by integers. Here is a typical example using enumerated. Ingredients is an array of strings, and by using enumerated, we loop over the array while also keeping track of each ingredient's position in the list. This method is useful in user interfaces or reports where a human-readable numbering of items is required. However, if your collection is more complex or requires indexing that isn't zero-based, you might need to use a different method to accurately reflect the actual indices. So for a more accurate way to handle indices, especially when working with collections that might be subsets or have non-standard indexing, we can use the zip function. This method pairs each element with its actual index, even if the collection has been modified. Let's consider an example where we start with an array of strings containing 3 ingredients. We then create a new collection, double ingredients, by using the drop first method. This method modifies the original collection to create a subsequence that excludes the first element. The resulting double ingredients collection is not a standalone array, but a view into the original ingredients array. This means that the indices in double ingredients retain their original values from ingredients and do not start from 0. Using zip to iterate over items and indices of the double ingredients collection ensures that we are using the correct indices corresponding to the actual positions in the subsequence. For a better interface over zip, we can also use the index method from Swift algorithms. It essentially encapsulates the same functionality, pairing each element of a collection with its index. It's a more succinct and expressive method call. In this example, by using double ingredients.indexed, each iteration of the loop provides a tuple containing the index and the element from double ingredients. This method automatically handles the pairing, making the code cleaner and reducing the complexity of manually zipping indices and elements. Next, let's delve into the technique of labeling loop statements to control the execution of nested loops in Swift. One of the lesser known yet incredibly useful features in Swift is the concept of named loops. This feature enhances the control flow in our code, making complex loop structures more manageable and readable. Named loops are not a separate type of loop, but rather a way of labeling loop statements. In Swift, we can assign a name to loops, for, while, or repeat while, and use this name to specifically control the flow of the program. This is particularly useful when we are dealing with nested loops, and we need to break out or continue an out loop from within an inner loop. The syntax for naming a loop is straightforward. We simply precede the loop with a label followed by a colon. Let's consider a practical example. Suppose we are working with a 2-dimensional array and want to search for a specific value. Once the value is found, we typically want to break out of both loops. The example code shows how we can do that with named loops. In this example, search value is the label for the outer loop. When value to find is found, break search value terminates the outer loop, preventing unnecessary iterations. In nested loops, it's often unclear which loop the break or continue statement is affecting. Named loops remove this ambiguity, making our code more readable and maintainable. Moving on, we'll explore the powerful concept of overloading the pattern matching operator for custom matching behavior in Swift. Swift pattern matching is an exceptionally flexible technique, usually used in switch statements to accommodate a wide range of patterns. In this context, an expression pattern within a switch case represents the value of an expression. The core of this functionality hinges on the pattern matching operator, which Swift utilizes behind the scenes to assess whether a pattern corresponds with the value. Typically, the pattern matching operator performs comparisons between two values of the same type using equals equals operator. However, the pattern matching operator can be overloaded to enable custom matching behaviors, offering enhanced control in data and how data is evaluated and handled. In our example, we have a custom type circle, and we implement custom pattern matching for it. We overload the pattern matching operator to match a circle with a specific radius. This overload allows us to use a double in a switch statement case to match against the circle. We can add as many overloads as we need. For example, we can define custom logic to check whether the circle's radius falls within a specified range. The switch statement will now be able to match my circle against double values and ranges, thanks to our custom implementation of the pattern matching operator. Custom pattern matching in Swift opens up a lot of possibilities for handling complex types more elegantly. By overloading the pattern matching operator, we can tailor the pattern matching process to suit our custom types. But as with any powerful tool, we should use it wisely to enhance our code without compromising on readability.
Yeah, it's pretty cool because, I knew that you could overload the operator, but I didn't know that you could have several overloads and use them in the same switch statement. So that opens up the way to some pretty powerful things indeed.
Yeah, that's pretty powerful, right?
And like you said, I think it's like with any custom operators, you want to be careful. You want to make sure that you use it like in a very consistent way across your app. Otherwise, yeah, I can really easily see this getting out of hand really fast.
Yes, we should be careful how many overloads we define for sure.
All right, so thank you for these tips. They were super nice. The first one about enumerated reminded me that in one of my very first videos, I had done a video on enumerated and mentioned that we were getting an index, and someone in the comments said, no, it's not an index, it's a value that represents the order, but it cannot be used to subscript the original collection safely like an index should. So great example, definitely.
Yeah, I also learned it quite recently, maybe a couple of years ago, and I was using enumerated for years before then. So I think it's great. It's a great thing to know.
Yeah, it's a great example to show, one example of the Swift algorithm package that I am yet to cover on my channel, and I've been looking for examples for it. Very happy to have this first example in one of my videos. And so, as I said in the intro, you've written a new book recently, Natalia, and so maybe you can tell us a bit more about it?
Yes, I'm really excited about it. And if you're looking to learn more advanced Swift techniques like the ones I shared today, I'm really thrilled to introduce you to my new book, Swift Gems. Over the years, I've gathered a collection of advanced Swift techniques that have significantly enhanced my projects, and I'm excited to share these insights with you. The book is tailored for experienced Swift developers looking to elevate their skills and refine their code. The tips are focused on the Swift language and Swift standard library, so they can be integrated into any project that uses Swift, from iOS and macOS to Swift on the server. I hope that Swift Gems will help developers appreciate the magic of Swift and take their Swift code to the next level.
That sounds super cool. So, as you can imagine, I can only recommend checking out your book. And of course, you have a link in the description to check out Natalia's book. You just need to click on it to see and learn a bit more about it.
And I also prepared a special discount coupon for the viewers of Vincent's channel. So if you want to check it out, please look at the comments below.
That's awesome. So thank you for that. And yeah, you will have the coupon also in the description. Awesome. So once again, a big thank you, Natalia, for being a guest in this new video and sharing these free tips with us.
Thank you so much for inviting me again.
Of course, if you also know some tips in Swift that you really enjoy using, don't hesitate to share them in the comments. As always, don't forget to like and subscribe to my channel so that you don't miss my next video. And I think I just have to say thank you for watching. Thank you again, Natalia, for joining me, and see you next time. Bye bye.